Hi, Nick here, M0NTV, and welcome back to my shack. And thank you very much to everybody that watched the last video. And at the end of that video, I gave a sneaky trailer for what this video is going to be about, which is this. And this is my Steerable IF Stack. And now we're going to get to see this, and you'll see this in more detail, and we're going to test it and everything. But before we get to that, I thought it'd be worth just backing up a little bit, and I'm going to show you some graphics and things in a moment to just illustrate how this is different to what I've done before. And actually just to think about how we get signals progressing through the IF section and what it looks like to steer the whole IF section as though it were one single module, which is effectively what we're doing here. So, hope you enjoy. Steering the IF section, and we're going to have a look at how we control the flow of signals through, well, what you could describe as the heart of a transceiver. And let's first of all just take it right back to basics. So what is the IF section? Well, IF, of course, intermediate frequency, and in a traditional superhet analog radio, this would be the heart of the old radio. So essentially, if we're talking about receive, your signal of choice would come in there and be fed to the mixer on the left, mixed with your VFO, mixed down to your intermediate frequency, and mine is 13.326 megahertz. And during the IF section, essentially, we're about two things: amplifying and filtering. So the first thing is we want to take what is usually a very weak signal and making it stronger. So that's amplification. And you usually would do a fair bit of amplification in the IF section. You also want to filter it, because you would use usually a narrow band crystal filter to filter out the opposite sideband to the one that you want. And then when you finish filtering and amplifying, you would feed the finished product to the product detector. And then you'd mix it down to baseband with the help of a signal from your BFO, and you listen to it. And on transmit, essentially it's just the same in reverse, except this time it comes in on the right hand side into what's now the balanced modulator from your microphone and your microphone amplifier. You do the same amplification, filtering, and then you send it out to the mixer where it gets mixed up to the frequency that you want to transmit it at. Now, in modern transceivers of a traditional superheterodyne architecture, IF stages can be more complex than this. Very often you would have some kind of automatic gain control, which would perhaps tap off a signal later in the chain, maybe from the product detector, sample it, see how strong it is, and based on how strong that signal is, it would send a bias voltage back to the IF amps to either turn the amplification up or down, depending on what's needed to balance that gain at a level that you choose. Now you'll see here, I'm not doing any of that. I'm keeping it really simple. And so my IF section is literally just what you're looking at on the screen. It's a first IF amp, it's a crystal filter, and it's a second IF amp, and that's what I'm going to go on. You will see in a moment there's plenty of room to manoeuvre to put extra things in and different things on receive and transmit, but that's essentially what we're doing. And so the only question is, if you're going to use the same crystal filter, which usually you would, how much of that IF section can you share on receive and transmit, and how much do you have to kind of switch in and out? So let's start with what I call the switched IF section. This was the second rig that I built, which was the Breadbin 80. this had this architecture. So basically what this is, you build two sets of amplifiers. So on receive, you'll see the signal proceeds through as the arrows dictate. But on transmit at the bottom, obviously you start on the right rather than on the left, but you just switch in the bottom set of amplifiers. Now there are advantages to this topology because it means you can have very different amplifiers for receive and transmit. If you want to put your AGC in on receive, you can. It won't affect anything you're doing on transmit. So yeah, there are advantages to it. It means quite a lot of switching, and also it means building twice as many amplifiers. So it's perhaps not the most efficient way of doing it, but it does work. And as I said, that's the way I did it when I first started designing my own radios to build. So that's the kind of switching the individual amplifiers in and out. There is, of course, another way, which is the bidirectional IF section. Now this I employed in my last rig. This is the one in the red bread bin, the so-called optimizer. And the advantage of this, and it is a large advantage, is that you have the modules there, as you can see, but on transmit, they're exactly the same. All you do is you reverse the current flow through the existing modules. And your amplifiers are bidirectional amplifiers that don't even need relays. You switch them via a bias control that you can switch in with the PTT. So the great advantage here is you only have to build one set of amplifiers, and once you've built them, they will do for transmit or receive. Disadvantages, of course, hard to do in AGC, although Wes Hayward has now produced a version of this famous bidirectional termination insensitive amplifier that has a variable gain and you could use in an AGC. So even that's possible. So that works really very well indeed, and it saves a bit of space as well. The amplifier is a little bit more fiddly to build, and in truth what you're actually building is two sets of amplifiers on one board, really, that are just switched by a bias control rather than a relay, but works very, very well. So what do I mean then by steerable IF section? Well, this, and I owe a great debt here to Pete Giuliano, N6QW, and to Charlie Morris, ZL2CTM, because they've both done some cracking work on this. Charlie's made videos. Pete's been using this same technique in a number of his rigs and in his recent ones. So essentially what's happening here is on receive, you have the same order of things as we've just been looking at. But on transmit, we do something different. So on transmit, you'll see, look at the arrows on transmit. Starting on the bottom right, you take your signal, which has come from your mic and your mic amp, through the balance modulator, as it is now on transmit, but you put it right round to the input of the first IF amp. And then the signal goes all the way through in the same order as it would as if you're on receive, except that when you get to the output of the second IF amp, that then loops all the way round and goes out to the mixer and on to your transmit amplifiers. So essentially what you're doing is you're treating the whole of the IF section as if it were one module, and then you're steering the whole thing. And what you're essentially doing is just switching what feeds it and where the output's going. And so the mixer and the product detector balance modulator will either receive or give signals to the IF section. Now, looks easy, doesn't it? You think, well, simple. And that's what I thought. I thought, well, I've messed around with relays and things before, how hard can it be? Well, actually, it turns out more tricky than you thought, but I'll say more about that in a moment. So this is essentially what I decided upon. And this wasn't the first iteration of this design, and there are different ways of doing it. To be completely honest, it proved a bit of a pig, actually. Quite hard, because I built one of these switching things first of all, and it seemed to be all right. I was testing it, as we're going to test it in a moment, and putting a signal through from a signal generator and looking at it on the oscilloscope. And I was looking at the oscilloscope. I thought, God, blimey, that's a strong signal. That's distorting. That is. So I turned the gain down on the SigGen. Didn't make any difference. So I turned it down more. Didn't make any difference. I switched it off. It didn't make any. I unplugged it. It didn't make any. And then your heart sinks when you realise that my IF amplifier has become an oscillator and was producing a perfectly respectable 13.326 megahertz sine wave all on its own without any input from anywhere else, which is clearly not good. So as I investigated this, I realised I'd neglected a fundamental thing. Now, if I'd paid more attention to Pete, sorry Pete, and to Charlie, sorry Charlie, and looked at their material in a bit more detail, they actually highlight this problem. And it's a problem that I'd never had to think about because I've never done this before. And that is this. If you're switching signals in to an amplifier, those signals by definition are going to be fairly weak. They're not going to be strong signals. At least they're going to be much weaker than the signals coming from the output of your amplifier, which are going to be much stronger. I mean, my IF stack had a gain, including the losses of the crystal filter, of 59 dB. Well, that's a lot of gain. Now, I had to pad it down, as you will see, by 6 dB, but that's still a fair old bit of gain. So that signal coming out of the second IF amplifier is a lot higher than the signal going in to the first IF amplifier. And what was happening somewhere, maybe on some unshielded cable, maybe on the pins of the relays, the way I'd got the relays wired up, some of that output signal was leaking into the input. And of course, once that happens, you've got yourself a perfectly respectable oscillator and a rubbish amplifier. And that was the problem that I've been having to solve. And it has been tricky, but you'll see what I did in a moment. One of the things I did do was part of the design. Now you'll see here, if we start on the top left at the mixer, I've marked where the relays are, these little arrows, and the little green connections are the receive connections. So these are the kind of normally closed connections that you would have when the receiver is receiving. So you'll see the signal comes out of the mixer, goes around the top, into the first IF amp, through the whole stack, then comes out to the right, then comes out to another relay, and then goes out to the product detector. And the good thing about this is you will notice that the line T2 and line T1, these are the transmit lines. So they're lines that are only used when you're in transmit mode. Just note that they are completely isolated on both ends by relays. That's helpful. There are designs that keep them connected one end and just disconnected the other, which is not so good because you can still get stuff leaking through there, whereas I've completely isolated them, which I was kind of playing it safe. Now if we start down the bottom right hand side, so let's imagine now we're going to be on transmit, and I've changed the colour of the little switches to red for this. So bottom right, that's what happens. So the first relay clicks over to the right. So on transmit, your signal comes from the balance modulator up line T1 on the right. When it gets to the top, that one clicks over there at the top, and so the signal goes through the first amp, crystal filter, second amp. When it gets to the output of the second IF amp. That one relay clicks over to the left, and then we're on line T2, and that takes your transmit signal up T2, and the last one flicks over, and then your signal goes to the mixer. So that's the principle of what I wanted to build and what I did eventually build, and this is what it looks like if I show you the schematic. So what I could have done, of course, is to use 4 relays because you've got 4 switching points, but I decided to use 2 double pole, double throw relays. So if we look at them, the relays, I've done what I always do and fit a reverse bias diode from the power in to ground, and that's to prevent the back EMF from causing problems. Just go and Google back EMF if you don't know much about that, but essentially it's what happens when your relay switches off, when it's been switched and it switches off, and you can get current flowing in the opposite direction, and that just safely grounds it. What I've done is I've kept the input and the output as separate as possible. So you notice the connection to the mixer is top left on the left hand side there, and the connection to the product detector balance modulator is on the bottom right on the second mixer, so that was a good thing. I put some RF shielding in, which is essentially just a bit of copper clad board, separated them and just physically tried to keep them apart, used shielded coax and tried to do a better job. So it's not difficult to do and seems to work. Now I've done this really very well. Well, I say that, but there was one issue I was getting on transmit, and I was still getting some strange results, and whenever I get strange results these days, my first thought now is, am I overdriving something? And turns out I was. And so on transmit, I wasn't getting the results that I thought I should be getting. I needed to investigate, so I've got some separate attenuators that you can stack up. So I put those on the output when I was on transmit and realised that I needed to just kind of pad that transmit signal down a bit. And so what I ended up doing, this is version 2, was to build a simple 6 dB pi attenuator on that output, and I did it on the second relay so that the signal that's coming in on line T2 on the first relay is the attenuated signal which gets passed on to the mixer. And with that, happy days. Seemed to work well, as you will see very shortly. And here is my Steerable IF Stack. And let me just try and show you. Now, if you've watched the previous video, you will have seen exactly what these individual modules look like, so I'm not going to hold forth on these. But there is one IF amplifier, and above that is the crystal filter. And there's the second IF amplifier. And then finally, the actual steering section, the relays. And you can see here, I've tried to get as much distance between those 2 relays as possible, with some RF shielding as well. And tried to keep, distance on the pins of the relays as well as much as possible, and try and kind of just keep stuff out of the way of other things. Now you'll see that pi attenuator there, which is on the transmit line T2, which is this bit of coax going around the top, and that's the 6 dB pi attenuator that I needed. But yeah, that is it, and obviously it takes up a lot less room when you stack it all like this, and a lot less external connections as well. So there's all kinds of bits of coax going around here, but there's only actually those 2 BNC connectors that kind of connect it to the outside world, to the mixer on the left, and to the product detector and slash balance modulator on the right. So, well, acid test then. Let's let's actually put it through its paces and show you that it does in fact work. So let me demonstrate the Steerable IF Stack. Now let me just show you first of all what we've got here. So if I come down here to the SIGGEN, hopefully you can see. So I've got channel 1 of the SIGGEN set to a very low, just 6 millivolts peak to peak sine wave at my IF frequency 13326, and that's connected up to the left hand port. That's the mixer port. So this is simulating the IF stack in receive mode. So there's a signal coming in, it's working its way through the amplifiers and the crystal filter and out the other end, and this is very long lead. I won't trouble you with that, but it comes down to the oscilloscope, and okay, so that's what we're going to be looking at the results on. Now if I just shunt along a bit, this is my dual power supply. What I'm going to do is power up in a moment on the left hand side. That will be main power to the stack, and the little alligator clips on the right hand side, the right channel, that it just comes up here, if I can show you, up to here, and that is this second lead, and this switches the relays. Okay, so when I power up this right hand channel of the power supply, that will simulate pressing the PTT and giving me power on transmit, and that will trigger the relays, which hopefully will flip everything over, and you'll see the signal die. And then what I'll do then is I will swap these connections over. So the in becomes out and the out becomes in. I'll connect the SIGGEN up to the right hand side and the oscilloscope up to the left hand side, and repeat the process, and hopefully you'll be able to see that it actually works. So but for now, let's simulate the receive mode. So we've got the signal there. Let me just come down here to the oscilloscope, and I'm going to switch on now the left hand side. This is the main power to the stack, simulating receive. Okay, so we can see there we've got just over 2 volts and nice clean sine wave, and so that's great. Now if I press the right hand one, that will trigger transmit mode, and so that signal should die away completely, because this is what would happen if I were pressing the PTT. Yeah, there we go, and so that completely kills it. And if I release it, yeah, there we go. So that works on receive. What I'm going to do is I'm going to pause the video now, and I'm just going to swap these 2 leads over, so out becomes in and in becomes out. So I've now swapped those leads. So if we look now, the left hand side is this long lead which goes all the way down, 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 round and into the oscilloscope, and the right hand goes to the signal generator. So what I'm going to do now is come back to the scope, and I'm going to power on, and of course I won't see anything because I haven't pressed the PTT, I haven't simulated the transmit mode. So if I press this, there we go. Now you'll notice I've only got about half as much voltage, peak to peak, coming out this way, and that's because, of course, I've got a 6 dB pi attenuator on the transmit line, and that will mean that for my voltage, that will be half. Got 6 dB, of course, is factor of 4 difference when we're talking about power, but when we're talking about voltage, it's half of that, so that will be half as much, which is exactly right. So that's there, and if I switch it off, nothing. So that's brilliant. So that works finally. Hallelujah. So there it is, and I got there in the end, which is a lesson in itself, really. I always say, building radios is not the difficult bit. The difficult bit is resisting the temptation to pick the blooming thing up and chuck it in the skip when it doesn't work. And just about every radio I've built, I've had that temptation more than once, I have to tell you. And that's the thing, it's hanging with it, and you get there in the end, usually, hopefully. So that's great. So myself, I'm probably going to start turning my attention now more towards the transmit chain. I mean, obviously all that bit that we've done there will serve both bits. I've already built the front end of the transmit chain, the microphone amplifier, and I can do something about that. I want to start thinking about the other end, actually, about the driver and the PA. But before we get to that, I've been asked about the little oscillator that I use, the Arduino Uno paired with the SI5351, and I don't think I've done a YouTube video about that before. In fact, I'm sure I haven't. So maybe that's a good one for a future video. Perhaps do that one next and look at what I do there. There's all kinds of stuff you can do with that. I tend to try and keep that simple if I can. There's a pattern here. But thank you very much for watching, and I hope that was of some interest, and I will see you on the next video. Cheers, bye bye.